Welcome to the first devlog for my unnamed dungeon crawler worker management simulation programming game, or however many tags I can cram into that sentence. This is a game about dungeon crawling, where the player programs the AIs of a group of characters who explore a dungeon and bring back loot to improve the town, which improves the characters, so they can bring back more loot to improve the town, etc. The player can directly control each character, but the focus of the game is automation and setting up all of the characters as a whole to efficiently explore the dungeon autonomously. And the focus of the automation system is on the behavior of individual characters rather than on configuring an overall economic crafting system or building a factory. As the player progresses through the game, they'll gain the ability to create increasingly expressive AI behaviors using a node-based programming environment. Under the hood, the AIs are actually WebAssembly executables, and eventually the player will unlock the ability to run arbitrary WebAssembly compiled from any language. That's for those players who want to explore the underlying API and write maybe more powerful behaviors. I also intend the game to have an asynchronous multiplayer mode where the players can upload their AIs to compete at running dungeons or farming or at arena fights, and then the player will receive back rankings, possibly in-game rewards, and the AI's memory stores, which they can then use to tune the behaviors in the future. With this project, I'm trying to capture the joy of writing little toy simulations and seeing the agents run around on their own doing whatever it is they do, like an ant farm, but in this case with swords and chests of loot. So where did this project come from? Some time ago, a friend of mine sent me some of the super cute ASCII art from a game called Stone Story, and we started to play it, and then discovered it had a programming mechanic, and both of us were super enchanted by that, especially the way the game stages complexity, where as you progress through the game, you become able to do more and more interesting things with the programming, and the game forces you to explore the programming environment. That was extremely well done. From there, we started talking about how much more fun some classic roguelikes, things like Angband or NetHack, would be if they were actually full programming games and you could automate them, and that became the core of this idea. I've also always been charmed by the asynchronous multiplayer in a game called Reassembly, which is like a ship design game where you build fleets. And when the player has beaten a region of space in that game, they can fly their fleet into a wormhole, which locally resets the game for another run, but it also uploads their fleet design, which then can be downloaded onto other players' computers, and in those local instances, the fleet becomes like a boss-level enemy. The player doesn't control it anymore, it's AI-controlled, but it's still there in other people's systems. I really like that mechanic, and I kind of wanted to go a little bit further by allowing the player to actually control those instances by controlling the AI, and that's what I wanted to get out of the asynchronous multiplayer in this game. So what is the game now? The basic dungeon crawling works, the low-level WebAssembly API works, the code editor and the behavior nodes in it are at a prototype stage. I've done the initial visual development and some story writing, but that needs more work. There is a lot of GUI work to be done. I'll need to get the game mechanics beyond basic melee and range combat, so that's basically the hardest part of game design is yet to be done. And also I'll need to design the complexity ramp that I'll use to gamify the programming. How do you introduce the behavior nodes over time? That's going to be a lot of difficult design work, not yet done. And then also the interface around the asynchronous multiplayer. Like I know how that server is going to be set up, and the code is prepared to run that way, but none of the details around it are done yet. So those things are all necessary. When will the game release? I don't know. I'm not planning on making this a very long project, but at this point I don't know when it will be done. So what is the game's tech? It's a bit of an abomination. It's a mix of Godot, Rust, and WebAssembly, which is, to be frank, kind of eccentric, but I'm really enjoying it. I think it's an interesting mix. Godot is there for all of the front-end stuff, so all of the 3D, all of the GUI, all of the user interface is in Godot. Rust is there for the core game. So all of the game logic, level loading, level data is in Rust. It hosts the WebAssembly environment. And that Rust part is what will be split off to make the headless server for the multiplayer version. The WebAssembly runs the actual AI logic. I chose WebAssembly because sort of quixotically, it was important to me that the AI be implementable in any language. And there's a big asterisk there. You can't really target WebAssembly from any language, but it has good support from a lot of languages, like C, like Rust, like C#, like Go, Python. All of those can, at least in principle, be used to implement an AI that will run in this game, transparent to the game itself. So I think that's great. With some compromises, like dropping that multi-language support for the AI, you could do the whole thing in Godot. I don't need any of the fancy Rust stuff, like performance or type safety or any of that for this game. It's fairly simple. Godot could do it all, and it would be nice. It would be a good environment to work in. Alternatively, if you wanted to go pure Rust, I could be doing this in Bevy. I really like Bevy. I've used it in previous projects, and if I were working in pure Rust, that is absolutely the engine I would be using. I chose not to use Bevy for this because all of my previous projects have been either in homebrew engines or in very immature engines like early Bevy. And I wanted to do something in a more mature, more mainstream engine. And I've complicated that by adding a bunch of other layers, but that's why I'm using Godot. And I'm actually really, really liking it. So I enjoy working in Godot a lot, and what it does very well, I think. And also, I felt that the sort of the monolithic player editable AI didn't lend itself very well to the ECS architecture. So I don't think I would be getting as much from a system like Bevy for this game as I might for other games. And so I think working with Godot and then engineless Rust and WebAssembly is a pretty good mix for this particular project. And that's it for this first devlog. Thank you for watching. I hope to see you in the next one, where I'll probably be talking about my palette-based texturing and coloring solution, which is very simple in Godot, but is working pretty well for me. And I think that'll be quick but interesting. So I hope you have a good day.